Okay.
You're on.
Yeah. So, hi guys. I'm Alex from Brazil, and today we'll talk more about how to deliver fast, stable systems. But before we starting about that, we just need to define uh, why legacy system is so bad. And after that, we can define better and present to you how to don't get legacy systems. And after that, we will detail in more deep one of these three steps. And it's not about only documentations and theory, but we will show how to code these things too. And in the end of the presentation, we will show how to get more information about these acknowledgements. And if you don't, if you cannot stay here uh, and you don't have a lot of time, you can just scan these QR codes now, and I can help you in another time. So about legacy systems, uh, why is so bad legacy system? Because the first thing is that uh, the legacy libraries and frameworks versions don't have a lot of people updating the documentation, and the community just um, don't update more the legacy versions. And guys like us, we need to search on websites and blogs. And this is not so good because the configuration changed, and there are a lot of configuration uh, misconfiguration because of these unupdated documents. Another thing is vulnerability. Legacy versions, um, there are legacy versions that the community just don't update and fix some vulnerabilities and no vulnerabilities that hackers can use to extract data from your systems. So this is not so good. And other bad thing is JDK versions. If you cannot update the system, you cannot use new features from the JDK. For example, streams, API, and a lot of new good features from JDK. For example, for Spring applications that are using Java 1.7, you cannot use the streams. So if you uh, cannot use legacy system, you just need to update the system. But what is the problem to update the system? The problem is when you update and discover some bug or break the system on production environment. If you discover in other phase of the systems, for example, in the development phase, it's not a problem. The problem is when you discover these bugs in production environment. So for you don't for your work with update system, you can just follow three steps here. For example, first you need to design the system using layers. Define better the responsibility of each layer and the dependency between these layers. After that, you just need to cover the system layers with tests. So in this step, you cover all this layer with tests, and you won't discover bugs on production phase, and you will discover bugs in development phase. After that, you can just update the system using some library or some tool. I will explain better after that. So for the first step, you can use some books. There are a lot of documentations and blogs on internet about that, but I will put here two books. That is Clean Architecture from Robert and Design Hexagonal Architecture with Java. This is examples of these layers. So here we have the clean architecture layers that we define here, the layer of frameworks and drivers. After that, interface. And after that, we have the application business rules. And after that, we have enterprise business rules. So each layer have some sorry, each layer has some responsibility, and each layer can define the dependencies between of them. Other example is hexagonal architecture, and there are don't have a problem if you choose from one architecture or other design architecture. You just have to choose one of these and develop your system according to these layers. You cannot mix some of responsibility from hexagonal in CleanArch or vice versa, but you need to choose some of them. The second step, I will cover in more details after that. But for the third step, we need to update the system. A good tool to do that is using Open Rewrite tool that updates the version of libraries and frameworks in a easy way. And you can use with Gradle or Maven. And another way is using AI agent. We are in a year of the AI, and we have Cursor and anti-gravity ADE to just chat with a agent and request to update the version of the application. Okay, but the second step, that is the step that we can just update and don't discover the bugs on production. So for that, in this presentation, we define the layers is from clean architecture. So we define the interface, the use case, and we will show how to create tests to each of these layers. So the problem here is the problem to do the second step is the developer needs to know a lot of annotation from the framework. For example, from Spring, there are a lot of annotations, and each of version of these frameworks adds more annotations, and the developer may confused about that. In this presentation, I will show how to use this annotation in a better way and help you to create more easily your tests. So for the first layer is the interface, and I define here a base class to create tests to controllers. So for example, we just create an abstract class and import some configuration using using the notation import. And We are using the Jackson auto configuration and logger bean factor for logger. Here is just to work with JSON request and response. And here we have a resource exception handler that will treat the exception from use case. So here is an example of controller test. So we can use for new version of Spring the web MVC test annotation that define a mock bean for us that is mock MVC bean, and we can use this mock MVC to perform some HTTP requests. And how we Spring know which class that we need to use to controller. We express we define using this field of annotation controllers and define the class of the controller. After that, the Spring can just create the controller bean, and when the mock MVC perform the request, the Spring just capture the request and pass through this controller object. And for controller test, we need to mock the dependence from this controller. So for example, here we have this resource that depends on this use case. So the use case is called inside the method of this resource, and we need to mock this dependence. So we can use Mockito library, and with Spring, we can use this annotation, mock bean, that creates a bean that have some object of Mockito. So we can just use this object and update the behaviors from this mock. So here we are update the behavior when the controller call this use case for this method with this input, the behavior is do nothing. So for this test, we just creating a new behavior for this dependence. And when the controller called this dependence, uh, the controller just return the response according to some configuration in this resource. For example, just return uh, 200 code, HTTP code, and this is a success code. And here is another thing that we can use from mock MVC. We can just define what is expected from the response from the controller. A tip for you is using a print handler, because this helps us in debug when we are just executing the test and don't get the right result. Here we can see what is the request, parent, parameters, and what is the headers. So this helps a lot. This is an example for controller. Now I just switch to use case test example. Here is a more simple test. This is a unit test. And here is example of Mockito library. Just mock some dependencies as repository and logger. And after that, we can just validate the behaviors from using of them. This is the main the main test that the application needs to have, because here we have the business rules, and here is an examples of the framework configuration that we need to put some annotation of the framework, for example, service. So in a use case, we need to define this use case with service annotation. So here is an example to validate if the use case are following this rule. And this is an example of the business rule. So here we have some depends of repository, and we just mock this return of repository with some fixture. And after that, we can validate that the repository save was called and capture the parameter and validate if the business rules is correct. For example, we can validate if the documents from the input um, is sent to the repository and database has this information. So here is an example of use case task. After that, we have a more difficult test that is repository or infrastructure test. Sorry, the Zoom tab is not so good. Just put it. Yeah. And for repository test, we need one more configuration that is a configuration between the framework and drivers from the infrastructure. For example, for Postgres, we need an library to create some infrastructure for us, like Docker and test containers. Another way is using memory infrastructure. So H2 can do a database in memory, and we can use this. But we have some limitations on here, and Docker infrastructure is more similar to production environment. So here is the best way to test according to the production environment. For that, we just configure the Spring with the environment variable from the Docker. For example, if the Docker with Postgres server has some ports, we just get these ports from Docker and from the test container and put on the Spring environment. And the Spring just creates some beans to us using drivers from J, oh, I don't know, the SQL drivers and JDBC drivers to Java, for example. And what is test containers? Test container is a library that creates some containers in a programmed way. So you can just create a lot of containers using code. So these are the best way to test when you need to test some infrastructure. And this can use it to Mongo, to Rabbit, any of type of infrastructure that you need to test, you can use that. If there are some image on Docker Hub, you can use. So for example, for repository, we have this annotation that is data J, JPA test, and this say-through Spring that we are needing to create beans for repository. And this other annotation just say to Spring that we don't use the H2 or memory database. We are using the test containers to configure the infrastructure. So here we just replace the auto configuration from Spring. And here is the container. So here we have a container that define all the things to test containers. And after that, we can use the information from this container to put on the environment variables on Spring. So here is just an interface that defines this method that receive register. And here inside this method, we just put in the registry the information from host and part of the container to Spring know where are our database. So after define the base repository class, we can just create some tests to our repository. For example, here we have some repository and we just request some save of some domain. And after that, we can find this domain that we are saved and validate if this domain was found on the database. And this is an example of repository. I don't know if someone has doubts, but we can just answer in the end of the chat because I don't have other monitor here. But I will try to answer in the end. Just take note of the slide number to help us with the questions. Sorry about that, but I will continue here. And about message is another infrastructure type of test. Here is another base class. Here we are just using Spring extension. So here we just starting the Spring context. We just don't start other beams configuration. So here we don't start database like repository, any of them that we don't start. We will just start the Spring context. And after that, we add some configuration in this context. For example, red child configuration class will add some beams that rabbit needs to work. After that, we can add more configuration. For example, for properties, we need some properties to configure a rabbit, and we need this configuration. After that, we can just add some custom configuration. Here for your system, you will have some class like that. This class just creates some queues and define the route keys to these queues, for example. And this is the Rabbit broker properties when you have customer properties like timeout and other configuration like that. So we can just import these configurations too. After that, I omitted here, but it's the similar from the repository. You just create some container that is creating Rabbit infrastructure. And after that, you can just using to uh, override the Spring configurations with the port and the host information from the container. And here is an example of producer test. We can just extend from the base class. And after that, we can test the producer. So here we don't have a lot of space in the slides, but we are just send a message. And after that, we can just recover this message and validate the content. It's a simple test to producer. But guys, this is the way to cover all the layers. If you have more question about other types of tests in each of these layers. You can access this QR code and you will fill some form and I will put in the chat to this link and you can help me to improve my presentations too. And now we can start with codes. I just change to AD. So for the first type of task, that is resource. So here is the code of the resource, and I will put some debug here just to help us to understand better the code. Oh, sorry, the Zoom is not so good with this menu. Yeah. Uh, Here we have some tests of research, and I will put the debugger here and just debug this test. Just start the Spring contact with the mock MVC. And now we have a bin with mock MVC. So you have all the configuration from the controller here. And here we have the use case, and that's great bean is from Mockito. So we have a mock object, like you can see here. And we define that when we call this method, this will do nothing. But here we can set all the things. We can set the return. We can set to throw some error. I have some example here. For example, we can throw some exception and define if the resource, the exception handler is working as expected. And I will just start. Yeah, so here the code is working as expected. And here we have some example of validation of errors. So here I will just change this thing and validate if the test is working well. So the test was passing. Now I will just change to 5. And now we can see how the print can help us with the bugs. Just put these. Now you'll see the print results. So here we can see the headers, the body, and we can see the response too. So here we can see the response and know that the validation is wrong or the response is wrong. Maybe the code is wrong and the response is wrong and the test is correct. For TDD is better when we define the right expectation here. So here is an example. Now we can just rerun and pass. Yeah. Now we'll just switch to other example. Okay, here we have Mongo. Now we have other example of tests. Here we have, I will put some debug here to understand better the test containers, but now I will just see how the test is working. Okay, and now just debug. And I will put the terminal to see how the Docker is working. Okay. Okay. Here we can see the configuration. So we have the configuration from the container. Oh no. Sorry guys. Just here. Here is my container and the port is 32796. And I will just search about them in the terminal. Here we have Docker. And now we can see the Mongo parts here. So we are using the same parts. So we can use the test container to create any of type of infrastructure. Just set uh, some image and we can use all the power of the Docker. And after that, we'll just execution. You can see the information from saved domain. And after that, we can validate the saved domain with the found domain. So this is another example of test. I think is that, Scott, and I will just change to slides, and we can answer some questions about that. And here we have my website, and I put some articles in Dev2, and you can send me a message on my LinkedIn too. So is that. And thank you for the opportunity.
Awesome, Alex. Okay. Thanks, Alex. So any questions? I know that,
I got a question for you. When you were doing the integration test with RabbitMQ, does it actually spin up a local RabbitMQ for the integration test?
Yeah, when I use it a lot, the RabbitMQ on my work, and we just use the test containers to
Okay, so it's from
start.
Docker. It's a RabbitMQ from a Docker container. Okay. Got it.
Yes, from to Docker container. I'm using the an image that start the Rabbit manager, and we can just using this to debug some wheel that is not is creating, and it's more easy to the developer to debug some errors of misconfiguration, for example.
Yeah, this is the part of integration testing that I have skipped many times. I do like integration with the database, I'm doing like actual integration with Postgres, or I also use the control layer to test the endpoints in isolation, but never done any like spinning up the message. We use ActiveMQ and never actually spin up an ActiveMQ locally to do integration testing. So that's the part that because when we roll it out to like when we run it on the Jenkins pipeline, we would have to do the same thing, and just having to spin up a Docker container and everything, it's just a lot more baggage that I have to carry.
Yeah, but what's the cost of not carrying it?
Yeah, I know. You want to have the test coverage, right? The integration test makes a big difference.
Yeah.
Yeah,
It's 9:45
and oh, sorry.
And you also
My-
do the integration test with the Kafka container too?
Yeah, Kafka gets spit up pretty quickly with the native image.
So you spin up like a Docker image for it too?
Oh, yeah, yeah.
Okay.
Spit up 3 brokers at the same time locally.
Hmm.
Amazing.
Yeah, I'm a big fan of the
my
test.
Alex just starts to say something here. I put mute here. Sorry. Yes, I have here some example of not Rabbit, but from Kafka. And we use it a lot in my work, and it is good to have this type of test, because when change the version of the production environment, we can just change in this test and know if something breaks. Some, for example, some configuration that don't have in production, or some new methods from the library from Spring that use Kafka or Rabbit. You can just see if something break when you update the versions. So for all the infrastructure, we need to create tests, and it's more easy to update when you have the test covering this library. So I I have a tip that is that we we need to cover all the layers and infrastructure too.
Yeah, agreed.
And like you said, when you have this type of test inside a pipeline and test all when you change something, maybe wrong configuration that a new developer just updating the version and think that will work and break. So the pipeline will save us with
Yeah.
this type of bugs.
You want to patch all of it in the CI layer, and yeah. Out of CI layer. Cool, thanks.
Very good.
Appreciate it. Where are you based at, Alex, in Brazil? Where are you, in Sao Paulo, Rio, or where are you in Brazil?
So I'm in the center of Brazil. I'm in Goiânia, Goiás. Is like um, interior of the center of Brazil. Yeah.
It's
It's near
center.
to the capital, that is Brasilia, but is in the center of Brazil.
Yeah, I work with a lot of people from Brazil, and They are in Sao Paulo or they in Paraná. But not in the center, not in the center of Brazil, where you live.
Yeah, I just starting to share context and you know more about the Goiânia. But the Goiânia now is a center of artificial intelligence, and we have a no center of intelligence that is SEIA, and we have some partners in USA too. Um, the biggest size in their intelligence, artificial intelligence, are in this center. So my teacher that's from the universe is the highest science in this center, and we are just starting to be known from other countries.
All right, so there we go. So thank you, Alex, for presenting for us. I appreciate it, and we'll I'll send you the link to the recording, and I guess we'll be in touch later.